after doing our math perspective, we're going to have to look at logic gates from a programming perspective because this will be what we're actually doing in Java. Okay, so our Java programming symbols are your ampersand for and, ampersand, a straight line for a caret for XOR, or you can call it an up arrow, and then you'll have your explanation point, or your kind of tilde looking thing for your not. Not, XOR, or an and. Okay, so most of the time you will see programming expressions look like 3 equals 4. Now, the double equal sign is the equality operator in Java. It checks to see if two things are equal. If you put 3 and 4 together, you know that 3 and 3 does not equal 4, so the equality operator will output a false. Okay? So to do these and, or, and XOR and not logic gates, what happens here is that you'll see 3 equals 4, and then you'll have like a ampersand, and then like 7 equals 7, and this condition is true, so this will give you a true. But you have this logic gate in here in the middle, the double ampersand, and the double ampersand will give you false and true, and false and true is false because both inputs have to be true. So we're just going to erase this real quick and make up our own little logic gate set out of Java characters. Okay, so let's just do our not symbol here, and then in parentheses we'll have our long expression. So this could be 7 plus 2 equals 9. And then you'll have your or symbol here, and you'll have or 3 minus 1 equals 7. And then you can have an and over here, and then with the and we'll just do true. So in Java you can either plug in variables or submit your own dumb equations like 7 plus 2 equals 9, and it's comparing 7 and 2 to 9, but most of the case this will represent a number that 7 plus 2 would be like a variable, let's call it a, and that you'll be checking to see if a equals 9 in Java. And for this true over here, this would be like inputting a variable, but in this case the variable is a Boolean. A Boolean can have a value of true or false, named after the mathematician Mr. Boole, which invented Boolean algebra. So Booleans can store true or false. Then you can have your conditions over here that can be true or false. Okay? So let's evaluate this expression using our NAXO. So not, we can't really do much right now because everything is in parentheses, so we just leave the not on the outside. 7 plus 2 equals 9, 9 equals 9, so this is true. Okay, true, or 3 minus 1 is 2 equals 7. 7 does not equal 2, so this would be false. Okay, and then you have your ampersand, true. Now in Java, they always evaluate the expressions before they do the logic gates. they call it logic in Java. I'm calling it logic gates, just because logic gates is the physical thing. So, you evaluate this. In Java, the program will also work to where it stops computing if it knows the answer. So if you have 1 or 0 and 1, or it will know that this 1 will automatically give the entire value of the expression as 1, and it will not even compute whether 0 equals 1, and 0 and 1 equals 1 or 0. Okay, and that will save the processor some time in adding and subtracting data that we need to keep our massive programs with billions of calculations going quickly. So we have true or false and true that we're still solving in the parentheses here. And we need to remember Naxo. So since we're doing the and next, so it's going to be false and true, which is going to be a false. And then after that, we do a true or false. So those two lead into that. This goes to that, this goes to that. So true or false? True or false is a true because only one input has to be on. But we have our negation tool out here. And since we're done doing everything in the parentheses, this negation will change the true to a false. Okay? So your output of this code is false. So let's erase this real quick. Why would we want to have a true or false output out of one line of code? Well, if we're doing loops or our control structures, like an if statement, so if we have if true, and then we have our bracket opening and it does some code in here and then closes the bracket down here. So if an if statement receives a true expression, the if statement will do the code on the inside, okay? And that's the same thing with if-else statements, okay? So if-else statements will also execute the code. If you have like 3 equals 3, they'll give you a true, and then it'll do if 3 equals 3, then 3 plus 1, and store that to a variable, okay? And that's pretty much what you need to know before you start doing these computations with logic in Java.